Set it. All right. We are getting ready to work on reviewing our DMR. You had a brand new DMR yesterday. We're going to take a look at a few of them that we missed, and that'll be that. All right, starting off with adding or subtracting. This one was pretty straightforward. You guys did great. There was no regrouping. So you should have typed a 3 in the ones place, a 3 in the tens place, and a 2 in the hundreds place. We are obviously subtracting because that's what that little symbol right there means. This type of answer, we did struggle on this vocabulary. When we are subtracting, that type of answer is called a difference. A lot of people said it was called a sum. A sum is the answer to an addition equation. This was a subtraction equation. All right. Moving on, we did great on multiplying. We did great on the fact family statement. We did well on the quotient of dividing. We struggled on story problem. The church collected toys for kids for the holiday. They collected 117 toys for toddlers, 206 toys for kids aged 5 through 11, and 98 toys for kids aged 12 through 15. How many more toys did the church collect for kids aged 5 to 11 than kids aged 12 to 15? The question is, are you going to combine or compare in this problem? And does this mean you add or subtract? Combine means to put together. So if we are combining, we are adding. Compare means to see how many more and how many less and what's missing. So this would be a subtraction equation. If we are seeing how many more toys were in this group of kids 11 to 15 than were in this group for kids age 12 to 15, that was a terrible drawing, then we're finding out what's missing. This part right here, we're going to get rid of it to see what's left. So we are in fact comparing, so we should be subtracting. This would be solved by looking at kids aged 5 to 11. There they are, and there were 206 toys. Looking at kids aged 12 to 15, there they are, and there were 98 toys. Lots of hopping around in this. So our equation would be set up as so. Okay, that will help you on tomorrow's DMR. Hint, hint, hint. Any questions on DMR? Anything that we solved together? Any of them that I skipped because you did well that you wanted to look at anyway? Any questions on those DMR skills? Feeling good? Okay. So that is the end of our DMR. Now you are getting ready to work on a assignment with me from your math books, but it's on Seesaw, called Lesson 6-3 Area. So allow me to remove your blocking, and you are going to go to your Seesaw. You are going to click on your activities and look at area, lesson 6-3, area, standard units. We are going to work on this together, just as we have in the past when we've had textbook pages. The first few pages we will do together. The last few pages will be yours for a grade. Our directions are to review the success criteria. We'll do that in a moment. We're going to watch a textbook video to get ourselves warmed up, and then we will add the response to begin working together. So first, let's take a look at our success criteria. That can be found in the instructional slides here. We are working on the highlighted section, finding the area of rectangles with whole number side lengths by modeling with unit squares. We talked yesterday about what unit squares are and how when we are measuring space that is covered, we have to measure 2 dimensions, 2D. Yes, that's where that comes from, the length and the width. Okay, so that's why we have square units, because we have to measure how long something is and how wide something is. Okay? So now we are going to watch this textbook video, and we're going to look at the examples of area inside of this video. So please watch, observe, and think critically about what you are seeing.
How can you measure area using standard units of length? Meg bought this United States sticker. What is the area of her sticker in square centimeters? You can measure area using standard units of area.
A square centimeter is 1 standard unit of area.
Here are some standard units of both length and area. How do the names of the standard units of length relate to the names of the standard units of area?
How are these related? So take a look. An inch, when we're working on area, is called a square inch. A foot, when we're talking about area, is called a square foot. A centimeter, when we are talking about area, is called a square centimeter. A meter, when we are talking about area, is called a square meter. What do you notice is inside of area, and how are they related? What's inside of area? Over and over and over again, what do we see? Y'all are scaring me. It's right here. Look, 1, 2, 3, 4, 5 times. They all have the same thing. What do we call it? An area. What do we call that? What is it? Leah?
A square.
That's right. So just like I shared with you yesterday in your notes, when you are working on area, you must use the word square. Sometimes you'll see that abbreviated or shortened as SQ. It's the first 2 letters of square. So this is the label that you should always have inside of area problems. If you don't have this label, I'm going to think one of 2 things. 1, you're giving me purple unicorns flying through space, which is going to make me very happy, but it's going to make you very wrong. Or I'm going to think you're solving a regular measurement that is not how big a space is, and you're just measuring how long something is or how wide something is, and that would also make you very wrong. Okay, so this word square tells me that you are measuring 2 ways. 1, 2. All right. Okay, very good.
The units of area contain the names of the units of length: inch, foot, centimeter, meter, as well as the word square. What would 1 square meter look like? It would be a square with each side 1 meter long.
So here are a few examples. If we had a poster that might be hanging on your wall, that poster might be 3 feet by 5 feet. This word feet tells us that our measurement and area is going to be what? Square meters, square inches, square feet, or square centimeters? Go ahead and unmute. What is it going to be?
Square feet.
That is right. The word feet right there. So we say square feet. Okay. Classroom floor is 8 meters by 12 meters. So what is the area label going to be?
Square meters.
Good. We've got the word square and we've got the word meters. What about this one? A postcard that you get in the mail.
Square
7
centimeters.
Oh, you're jumping ahead of me now, but you're right. 7
Square inches.
centimeters by 10 centimeters. So that's going to be square centimeters. And our final one, a book,
Is square inches.
because it is inches by inches. So if we were to draw a picture of this book, it would be 6 inches by 11 inches. So if we were to draw all of those tiny squares inside of there, we would see square inches. That's a terrible drawing. Don't judge me. All right, very good.
To find the area of Meg's United States sticker, count the unit squares. What square unit is used to measure the area of this sticker? Square centimeters are used to measure the area of this sticker. How does the grid help you find the area?
You practiced this yesterday. How does the grid help us find the area where this map is? How does it do that? Josh, help me out. How do these grid squares help me find the area? What can I do?
Count the squares.
Yeah, 1, 2, 3, 4, 5, 6. So if each one of these is a centimeter, this has an area of 6 square centimeters because I can see 6 squares inside of the sticker. Very good.
The grid shows how many square centimeters cover the sticker. How many unit squares cover this sticker?
Select your answer.
Oh, Josh just gave us the answer.
6 unit squares cover this sticker. The sticker is measured in square centimeters. So the area of the sticker is 6 square centimeters. Now you know how to measure area using standard units of length.
All right, now that we are warmed up on remembering what area is, I'm going to ask you to go to Seesaw and click on your activities. We're going to work on this response together for the slides that say with your teacher, and then we will end with the slides that are independent for you to work on. Again, I would recommend you make your screen smaller and put your Seesaw response here, put your Zoom over here so that you can see my screen and your work at the same time, because whatever I am writing, you should be writing as well. So I'm going to add my response as you are pulling up your responses. And you will see that we will start out with a nice purple slide that says with your teacher, because these are the slides that you're going to do with your teacher. Awesome.
Who is our
Okay.
teacher?
I don't know, Terrence, who is your teacher? Slide 2 is where we are going to begin. Go ahead and go to slide 2. Review this example with your teacher. All right. Draw a square to represent 1 unit square. Okay, I'm going to do that. Let's draw a square. I am drawing a square, so you are drawing a square. Boop, 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 boop. Okay, this represents 1 square unit. Boom, done. Use your unit square to draw a rectangle that has an area of 8 square units. So now I'm going to draw 8 square units that are mushed together to represent a rectangle. Go ahead and do the same on yours. Good, I'm seeing some thumbs up. The next question says, compare your shape with a partner's shape. What is the same? What is different? Okay, I'm going to send you into a breakout room with one other person. Hopefully it works. If it doesn't work, we're going to stop on breakout rooms. And you are going to share your screen with that one person and look at how your rectangle is the same and look at how your rectangle is different. Okay. All right, here come your invites. Go answer those questions. How many of you, when you compared your rectangle to your partner's, your rectangle was bigger on the page? How many of you? Your rectangle was bigger than your partner's. Okay, so in the other half of you, how many of you, your rectangle was smaller than your partner's? Yeah, so that's what this is pointing out. When we just say square units, we don't have an exact measure of how big that is. Take, for example, if I say that I'm going to give you a piece of cake and I'm going to give you 6 square centimeters of a piece of cake, but I am going to give someone else 6 square inches of a piece of cake. They're both 6 squares, but one of those is going to be a bigger piece of cake. Even though they're both squares, the inches cake is going to be larger than the centimeters cake. So when we are using square units, it's important that we're precise with the size so we can say exactly how large or how small an area is. Okay? Go ahead and move on to slide 2, please.
We're already on slide 2.
Oh, I apologize. Page 2 of the work, slide 3. Thanks, Terrence. Good call. This is the example from the video that we looked at when we counted the square units of the sticker. The sticker had an area of 6 square units, which was 6 centimeters. Down here it says, if square inches rather than square centimeters were used for the problem of the above, would more unit squares or fewer unit squares be needed to cover the shape? Let's get our typing tool ready. We know that inches are bigger than centimeters. So if I were going to use inches to cover up that same rectangle as we see right here, then I know that I'm going to need less. I'm not going to need all 6 inches to cover up a space of 6 centimeters. So less squares. And if I am typing, you are typing. Because, and in math, you can use shorthand to make something shorter, and B/C represents because. Less squares because inches are bigger than centimeters. And again, in math, you can use shorthand. Centimeters can be abbreviated CMS. So we are going to know that we need less squares when the squares are bigger to cover a space. All right, let's look at slide 4. Slide 4 says, follow along with your teacher. There we go, Leah. Now I'm on my game. Follow along with your teacher. Do you understand? We're going to check if you understand, and then you will get ready to move on to work on the next portions coming up in breakout rooms. If Meg's sticker on page 314 measured 2 inches by 3 inches, what would its area be? Okay, 2 inches by 3 inches. Let's go ahead and build this. Grab a shapes tool and grab that orange square. And I'm going to duplicate it because it said that it was 2 inches. So I'm going to put 2 of these on top of each other. And then I'll label it. 1, 2. So that's my 2-inch squares. Then it says by 3 inches. So I'm actually going to duplicate this square a couple more times. Duplicate. There's 1, 2, 3. So now it's 3 inches across, and I can label that. 1, 2, 3. So we have 2 inches by 3 inches. Now we know that rectangles have to be full on the top and the bottom. So I'm also going to duplicate it and fill it in down here. Oops. So we have just created a sticker that is 2 inches by 3 inches. What would its area be? Well, let's count. 1, 2, 3, 4, 5, 6. So its area would be 6. Who can tell me why I'm wrong? Why is 6 wrong? What must we have inside of area? 8 and G. 8 and G.
We must have a, wait a minute. We must have a,
It starts with an L and rhymes with Rabel.
label.
We must have a label. That is correct. Who can help me out? What is the label inside of area? What have we said 1,500 times? Terrence?
Squares.
That's right. So we must have 6 square, and I'm going to use that SQ, inches, because this problem said that we're using inches. 2 inches by 3 inches. So inches must be in my label. So the area is 6 square inches. Awesome. So now looking at our next one, question 2, Zoe paints a wall that measures 8 feet by 10 feet. What units should Zoe use for the area of the wall? Explain. Well, we know it's going to be squares. We've said that a bunch of times, but the wall is 8 feet by 10 feet. So that tells me that she should use the area of square feet. I'm not done because the text or the question asks me to explain. So square feet, because, I'll use that B/C again, the wall has 2 dimensions. Oops. Square feet because the wall has 2 dimensions in feet. So that phrase 2D and 3D, when something is in 3D and it can pop out to you, that is because, and you do not have to draw this, this square, I'm just going to talk while you're typing. This is a 2D shape because it has 2 dimensions or 2 locations that we can see. We can see what's going from top to bottom. We can see what's going from left to right. We cannot see what is behind it. So this right here is a 2D shape. We can only see 2 dimensions or 2 sides of it. When we get to 3D shapes, that's where we can see 3 things. In 3D shapes, we can see the top to bottom, the left to right, and the front to back, or in front of and behind. So this is why it's called a 3D shape, because our eyes can see 3 locations on the shape. Area is always 2-dimensional. Okay, area will always only be the flat surface of one part of a shape. Okay, this is area. This is the only part that you have to do down here. Okay. I will also put this in the chat in case you need it. And then we are going to move on to slide 5. Alrighty, slide 5 says follow along with your teacher, and then I'm going to release you to some breakout rooms. This is the last type of example that you will do in your breakout rooms. In 3 and 4, each unit square represents a standard unit. Count the shaded unit squares, then write the area. Remember, when you write the area, you've got to include your label. Okay? Let's take a look here. I can see that I have 1, 2, 3 square feet as my length, and I have 1, 2, 3, 4 square feet as my width. I know the area is multiplying 3 times 4. So 3 times 4 gives me an answer, a product, a area of 12, but I have to have my label. So my answer is 12 square feet. Questions on number 3? Okay, let's take a look at number 4. If you'll excuse me for one moment. All right, number 4. I'm going to count my length. 1, 2, 3, 4, 5, 6 squares. So I'll label that as a 6. And my width is 1, 2 squares. I know that to find area, I can touch each square and count, or I can multiply. 6 times 2, 6, 12. So this also has an area of 12 square, but we're not going to say feet. Look at this label. These are square M's. Even if I don't know what M's are, that's what the textbook's telling me, so that's what I'm going to do. M equals meter. 12 square meters. So both of these rectangles have 12 square units on them, but they're different for 2 reasons. One is their shape. This one on the bottom has a longer side. These have a shorter side, but this is also longer than 2. So their shape is different, and they are also different because of the type of label that they have. Questions on 3 or 4? Okay. Slides 6 and 7 are going to be completed in your breakout room. I'm going to give you about 6 minutes. That's 1 minute for each question. And then I will show you the correct answers when we get back. So slides 6 and 7 are what you and your group are getting ready to talk about in your breakout rooms. Are there questions over that expectation for slides 6 and 7, what you are going to do? Christopher.
Can you do back to slide 5?
In a moment. This one right here? Yep, there you go. Any other questions about the expectation? Okay, I'm going to put you in your breakout rooms. You are going to solve slides 6 and 7. I will show you the correct answers when you get back. Alrighty, that should bring us back. Go ahead and look at your slide 6. I'm going to put the correct answers up. If you have a question about one of the answers on slide 6, please let me know. These are the correct answers that you should have found. Any questions or comments on any of the areas on slide 6? Biggest thing to focus on here is to make sure that you have those labels. Square inches, square feet, square inches. If you only have the number, you are incorrect. Okay, let's move on to slide 7. Here are the answers that you should have found for slide 7. Problem 8 is 63 square meters. Problem 9 is 35 square meters. Problem 10 is 20 square feet. So I use my dot here and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there are 16 squares shaded in that picture. So my answer is 16. If you find it difficult to count each individual square, you can also use multiplication. 1, 2, 3. So I would multiply 3 times the other side. 1, 2, 3, 4, 5, 6. And we know that 3 times 6 gives us a product of 18. 2 ways to count there. Does that bring more clarification, Levin, or is that still confusing? Okay, thumbs up from Levin. All right, alrighty. Slides 8, 9, 10, and 11 are your independent work. So slide 8 is just telling you it's your independent work. Slide 9, the directions are at the top and you have 6 problems to solve. Okay. Remember, if you are struggling to see, you can use the zoom in tool and you can make the items larger. So if you're struggling to count those squares, zoom in and then you can see them more easily, and you can even write here. And then when you zoom out, it will still be there. So feel free to use the zoom tools, because I know that sometimes it's hard to see those light blue squares. So you can zoom to help you see that better. Okay. And that zoom is that magnifying glass up in the corner. So on slide 9, you're going to count the shaded unit squares and write the area. On slide 10, you are going to answer 3 questions, one about shape A, one about shape B, one about shape C, and there's a video here
Max has
that will read the problem to you. Actually,
the 14 stick.
no, there's not. The person who made this forgot to take that off. That's a video from my old lesson. So no, there's not a thing to read to you. You can have an adult read to you. I apologize. All righty. Slide 11 is for you to rate yourself as always. Remember, you are saying what level you think you are at. You are either at a level 2, 3, or 4. Level 2 means that you still feel like you're learning the vocabulary and you don't know what the concept is. Level 3 means you think you've got it pretty okay. You might just need some more practice. And level 4 means I could teach this to somebody and I'm ready for harder problems. And you're going to have to explain why you think that using vocabulary here on these lines. Okay, so again, your task for today is slides 9, 10, and 11.